Imagine for a moment that you're gazing at the most extreme black hole physics allows to exist. It's not like those normal black holes we know, with their event horizons forever hiding their secrets. This one is different. This is a naked singularity, a black hole without an event horizon, where all the infinite density, all the extreme curvature of space-time, is completely exposed to the universe. If this truly exists, we're talking about an object that could literally break the laws of physics as we know them. Today, we're diving into one of the most controversial and fascinating concepts in modern physics, naked singularities. We'll discover why the brilliant Roger Penrose believes they might exist, why other scientists find that impossible, and what would happen to reality if we encountered one of these cosmic creatures. Get ready for a journey that will challenge everything you think you know about black holes. Welcome, cosmic explorers. We're on an incredible journey toward 1,000 subscribers, and each one of you makes this adventure through the universe even more special. To understand what a naked singularity is, we first need to recall what we know about ordinary black holes. Imagine you're holding a basketball. Now imagine compressing all the mass of that ball into a point smaller than a pinhead, while retaining all its original mass. Gravity would become so intense that not even light could escape from a region around that point. This region is what we call the event horizon. The event horizon acts like an impenetrable cosmic curtain. Once something crosses this boundary, it disappears forever from our observable universe. It's as if the black hole wears a perfect cloak of invisibility, hiding its central singularity, the point where density becomes infinite, and the laws of physics as we know them simply cease to function. But what if that curtain didn't exist? What if the singularity were completely naked, exposed to the universe? That's exactly what a naked singularity would represent. All the infinite density, all the extreme curvature of space-time, completely visible and accessible to the rest of the cosmos. To visualize this, imagine a hurricane. In a normal black hole, it would be like you could only see the outer clouds of the hurricane, never the eye of the storm. A naked singularity would be like having direct access to the most violent center of the storm, without any protection or barrier. The idea of naked singularities originated from the work of British physicist Roger Penrose, one of the giants of modern physics. Penrose, who won the Nobel Prize in Physics in 2020 for his contributions to our understanding of black holes, proposed something that shocked the scientific community. Perhaps not all singularities are protected by event horizons. Penrose formulated what became known as the cosmic censorship conjecture. This conjecture suggests that nature has a kind of cosmic modesty. It always hides singularities behind event horizons, protecting the universe from their most extreme properties. But Penrose also showed that, under certain very specific conditions, this censorship could fail. Think of the cosmic censorship conjecture as a law of cosmic decency. It's as if the universe says, certain things are so extreme they shouldn't be seen directly, but Penrose discovered that this law might have loopholes. Penrose's work opened a scientific Pandora's box. If naked singularities truly exist, they represent regions where we could, theoretically, directly observe the effects of infinite density. That would be like having a window into the most fundamental and extreme aspects of reality. Other scientists, however, were deeply uncomfortable with this possibility. Stephen Hawking, for example, was a fervent advocate for the idea that naked singularities cannot exist in nature. He argued that their existence would create fundamental paradoxes in physics. But how could a naked singularity form? According to our current understanding, there are some fascinating theoretical possibilities. One involves the collapse of a very rapidly rotating star. When a massive star collapses, it normally forms a black hole with an event horizon. But if the star is spinning extremely fast, the centrifugal force might prevent the complete formation of the event horizon, exposing the singularity. Imagine an ice skater doing a spin. When they pull their arms close to their body, they spin faster. Now imagine this taken to the cosmic extreme. A star collapsing and spinning so rapidly that the rotation itself interferes with the formation of the event horizon. Another possibility involves electrically charged black holes. In theory, if a black hole accumulates enough electrical charge, the electromagnetic repulsion can compete with gravitational attraction in such a way as to expose the singularity. It's as if two titanic forces were in a cosmic tug-of-war, and the result was a naked singularity. But here's where things get truly unsettling. If naked singularities exist, they would break one of the most fundamental principles of modern physics, causality. In a naked singularity, we could, theoretically, receive information from the future or send information to the past. This would create temporal paradoxes that would make time travel movies look like child's play. Think of it this way. It's as if a naked singularity were a hole in the fabric of reality, where normal rules simply don't apply. Near a naked singularity, time could flow backward, effects could precede their causes, and the very notion of temporal sequence could disintegrate. Debates about naked singularities remain intense in the current scientific community. Some physicists propose that, even if they form initially, naked singularities quickly develop event horizons, dressing up and becoming normal black holes. It's as if the universe has a self-correction mechanism that quickly covers any naked singularity that dares to appear. Other scientists suggest that naked singularities might exist, but only under such extreme and specific conditions that they are practically impossible to find in nature. It would be like looking for a needle in a haystack, the size of the observable universe. Recently, some researchers proposed that certain astronomical observations could be indirect evidence of naked singularities. They suggest that some extremely bright and energetic objects in the distant universe could be powered by naked singularities. But these ideas are still highly speculative and controversial. The search for naked singularities represents more than just scientific curiosity. If they exist, they could give us unique insights into the fundamental nature of gravity, time, and space. It would be like having direct access to the source code of the universe, to the most basic equations that govern reality. Imagine if we could study a naked singularity directly. We could finally understand how gravity behaves under extreme conditions, how time truly works at fundamental scales, and perhaps even discover clues about the quantum nature of gravity, one of the greatest unsolved mysteries in physics. But this possibility also brings theoretical risks. If naked singularities can break causality, they could make the universe fundamentally unpredictable. It would be like discovering that the laws of physics have exceptions that can appear at any moment, making all our scientific understanding uncertain. The debate about naked singularities also forces us to confront the limits of our knowledge. We are dealing with conditions so extreme that our current theories may simply not be adequate to describe them. It's possible that we need a completely new theory, perhaps a quantum theory of gravity, to truly understand if naked singularities can exist. Some physicists argue that the very question about naked singularities might be ill-posed. They suggest that, when we finally develop a complete quantum theory of gravity, we will discover that singularities, naked or clothed, simply do not exist. Instead, there might be something completely different and even stranger at the centers of black holes. Meanwhile, the search continues. Increasingly powerful telescopes scan the cosmos, looking for signs of objects that could be naked singularities. Supercomputers simulate the extreme conditions where they could form, and theoretical physicists continue refining the equations that could predict their existence or impossibility. The question of naked singularities reminds us of something fundamental about science. Whenever we think we understand the universe, it surprises us with even stranger and more wonderful possibilities. Whatever the final answer about naked singularities, the journey to discover it is expanding our understanding of the deepest aspects of reality. So, recapping our cosmic journey today, we explored the fascinating and unsettling possibility of naked singularities, black holes, without event horizons that would directly expose infinite density to the universe. We saw how Roger Penrose opened this scientific Pandora's box, how these entities could break the laws of physics as we know them, and why the debate about their existence continues to divide the scientific community. Perhaps the deepest question naked singularities pose to us isn't whether they exist, but what their mere possibility tells us about the nature of reality. Do we live in a universe where the very fabric of space and time can have holes, where the laws of physics can have exceptions so extreme that they challenge our most basic understanding of causality? These questions connect us directly with our human condition. We are beings who evolved on a tranquil planet, orbiting an ordinary star, trying to comprehend phenomena so extreme they challenge our very capacity for imagination. And yet, through mathematics, observation, and creative thought, we manage to at least glimpse these extraordinary cosmic possibilities. Cosmic explorers, now I want to hear from you. If naked singularities truly exist and break the laws of physics as we know them, would that make the universe more fascinating or more terrifying for you? Share your reflections in the comments. I love reading your perspectives on these cosmic mysteries. And since we're talking about mysteries that challenge our understanding, what unexplained aspect of the universe do you want me to talk about in the next video? Wormholes, dark energy, the nature of time? Leave your suggestions in the comments. We're on an incredible journey toward 1,000 cosmic explorers. If this video expanded your mind about the universe's most extreme possibilities, join our crew by clicking subscribe. Every new explorer brings us closer to unraveling the cosmos's secrets together. Like this video if it made you question the very nature of reality, and share it with someone else who is also fascinated by the extreme limits of physics. In the next video, we'll explore another mystery that challenges our understanding of the universe. Until then, keep looking at the stars and questioning the mysteries they hold. The universe is far stranger and more wonderful than we can imagine, and every question we ask brings us one step closer to understanding our place in this infinite cosmic dance.